Welcome to Chapter 3, Section 2, Real and the Complex Number Systems. In this section, we will study the set of integers and important extensions of the natural numbers. In our previous discussions, we learned that the natural numbers are useful for counting and ordering objects. However, natural numbers have limitations. For example, consider the equations 5 minus 8, which is the result is not an element of natural numbers. The result is negative 3, which is not a natural number. Similarly, many real-life situations such as financial debate, temperatures below zero, and elevations below sea level require numbers that are less than zero. To overcome these limitations, mathematicians introduced the set of integer denoted by z. The set of integer include positive numbers, negative numbers, and zero. It can be written as negative, actually it is 3 dots, negative 3, negative 2, negative 1, 0, 1, 2, and 3 dot, and so on. That is continue. By extending the natural numbers in this way, subtractions become possible without always leaving the number systems. Next, let us examine the basic operations on integers. Additions, subtractions, and the multiplications are all closed operations on the set of integer. This means that whenever we add, subtract, or multiply two integers, the result is always another integer. For example, 4 plus negative 7 equal negative 3. And the negative 5 multiplied by 2 equal negative 10. Both results remain under set of integer. However, division is not always closed in the set of integers. For example, 5 divided by 2 equal 2.5, which is not an integer. Therefore, division does not always produce an integer result. The set of integer also satisfies several important mathematical properties. The first is commutative property, which tells us that changing the order of the number does not affect the result of addition or multiplications. For example, 3 plus 5 equal 5 plus 3. 4 plus 2 the same with 2 plus 4. The second is associative property, which allow us to group numbers differently without changing the result. The third is distributive property, which connects multiplication and addition. This property simplify calculations and form the basis of algebraic reasoning. Integers also have a special identity element. The number 0 is called the additive identity because adding 0 to any integer leaves the number unchanged or unchanged. Likewise, the number 1 is called the multiplication identity because multiplying any integer by 1 leaves it unchanged. Another important concept is the additive inverse. Every integer has an opposite value that adds to 0. For example, the additive inverse of 5 is negative 5, and the additive inverse of the negative 8 is 8. Together A number and its additive inverse always produce 0. Finally, we study order relations among integers. Just as a natural number can be compared, integers can also be ordered. We use symbols such as greater than, less than, and equal to. Important properties include the law of trichotomy, which states that for any two integers, exactly one of three relationships is true: greater than, less than, or equal to. We also use transitivity, addition, and the multiplication property to compare and manipulate inequalities correctly. In this session, we have explored the set of integers, their operations, properties, additive, inverse, identity, elements, and order relations. These concepts expand our understanding of number systems and prepare us for the study of rational numbers and real numbers in the upcoming sessions. See you in the next session.